if I want to graph a logarithm, I want you to really realize how it impacts from an exponential function. So, okay, exponential functions had their asymptotes where? Yeah, on a normal one, unshifted, would be on the x-axis. And how did we get the t-table to graph an exponential function? Since I'm doing a base 2, I can go as high as 3. And then how did I get the y's? Yeah, because I took them each to the power, 2 squared, 2 cubed. I'm putting it in for x, which means my numbers are 1, 2, 4, 8. Okay, so, all right. We know if I plot that up 1, up 2, up 4, up 8, my exponential function should go shooting up really fast and then follow the asymptote. This is the beauty of logarithms. A logarithm is an inverse of an exponential function. So if it's an inverse, what should happen to those x and y coordinates? They should switch. So if you have a base 2 here, you got a base 2 here, all you need to do is switch those. The 1, 2, 3 goes on the right, and the 1, 2, 4, 8 goes on the left. You just need to switch the coordinates. Now, since this is your first time graphing log, I have you graphing the exponential function first, and then the log. So you'll do the t-table for one, then you'll just switch it for the other. My question is, where is the asymptote on a logarithm going to go? On the y. Yeah, since we switched x and y, now it's down the y. So if you're graphing a logarithm, you're going to have your asymptote going vertically, and then you're going to plot these points. So now you're going 1 over 0 up, 2 over 1 up, yes, 4 over 2 up, and then 5, 6, 7, 8 over 3 up. So I've got a curve going out to the right, and then has to follow the asymptote. So yes, it's going down the asymptote. So on a logarithm, you go down the asymptote. And remember, we said logs always have to have positive values. Notice this entire graph is on the positive side of the axis. This log always has to keep positive values. And so whereas an exponential function rises very fast, a logarithm rises super slow, like forever slow for it to get any height. Because you notice, the next time when I want to go up 4, I'm going to be 16 out. And then I'm going to be 32 out before I'm even 5 units high. I'm going to be way far out to the right before I ever get any height on this thing. So logarithmic scales grow extremely slow, and that's why they measure earthquakes. The Richter scale is a logarithmic scale. When you hear an earthquake was a 5 and then another earthquake was an 8, if they graph it, because that's a huge amount of power, that means it was 10 to the 5th versus 10 to the 8th in power. Okay, when it goes from on the Richter scale, when it's a power of 5 to a power of 8, the difference in that is 3. 10 to the 3rd is 1,000. That means this earthquake is 1,000 times more powerful than the one that was a 5. So when those numbers on the Richter scale go up, they're going up by powers of 10. So there's a huge monster difference in the power of an earthquake with just a little bit of difference in those numbers, all because it's on a logarithmic scale. So that's kind of important. So if you look at that first problem, I'm going to do yours in a second. Not the first problem, the second problem. Want one that's shifted. So you're going to graph 4 to the x minus 3, minus 6, and then you're going to graph, I ask you on the same graph to graph both of these. Okay. Where's this baby shifting? Okay. Both of them have a minus 6 in back. But then the first one will be to the right 3. Okay. So they're both down 6 because they both have a minus 6. Notice both of them have a quantity. X has been changed to x minus 3. Right 3. So they both went right 3. when I do that, I'm gonna shift them both to the exact same location. I'm not gonna shift them to two different places on you. So you're gonna go right 3, down 6, and then you're gonna do your t-table for your exponential function, plot it, then you're gonna switch the x and y's, and plot your logarithmic function. In this case, what power of x are you putting in your what base power are you putting in this? 4. So these are base 4s, so you're going to graph these with 4 to the x is how you get your coordinates. But they're both going to go, you're going to have an asymptote for exponential going horizontally through this point, and then you're going to have an asymptote going vertically through that same point. They're all going to count from the same place. I'm not going to mix it up on you this year. So, well, graphing logs isn't bad. You can graph the exponential, you can graph the log.